Hey y'all, it's your main math teacher, Mr. Boyd, and I'm back at it again today. We're continuing our discussion of right triangles, and today we're going to be talking about special right triangles. Okay, and this is what it's normally called. What we mean by special is there are two types of special triangles, and we've got them both on the screen right here. The first one is affectionately called the 45-45-90. And the reason we call it that, it has two 45-degree angles, 45-45, and it has a 90-degree angle. Okay, and what would you guess this one is called? Look at the angles. This is a 30-60-90 triangle. Okay, and here's why we call them special. They occur relatively frequently in our studies, and there's some really nice little properties to them that make them easy to solve and easy to work with. So anytime we can relate things to this, life is a little bit more convenient. So I think you should absolutely have these diagrams drawn on your page, because this is what I'm going to be using throughout the lesson today, and I'm going to try to use this to make things a little bit easier for you as we go. So this is going to be the stuff that I'm going to refer back to as we go. And here's basically the facts. Guys, look, this is the little guy right here is a square. And so if you've got x here and x there, remember, it's a square, so all the side lengths are the same, right? And then you have this line that goes down the middle. That's x root 2. Now let's talk about why that's the case. I want you to think about the Pythagorean Theorem. Okay, so I'm going to go ahead and call this A and B and C. So I know that A is x, so that would be x squared. And B is x, so that would be another x squared. And C, let's say that I don't know what C is. What I'm going to do is I'm going to show you why that is what it is. Okay, so let's say I just think that's C squared. Well, I'm going to do a little bit of math on this and see what happens, okay? I see I have an x squared and an x squared, so that's 2x squared because they're added together. And I'm wanting to know what C is, so I'm going to take a square root on both sides. And I get that I have a square root of 2 and a square root of x squared, and I have this square and that square root that cancel out. And so the square root of x squared, hey look, I have a root and a square together. Those are inverses, so they cancel out. So that is an x, and that's a root 2. And usually we write them in the reverse order. Now it's multiplication, so I'm totally allowed to do that. Oops, not equals 0, equals c. Okay, and so that explains where that comes from. Okay, that's a relationship that'll hold up no matter what x is. Now notice I didn't use numbers. I just said, it's x. If it's 6 or 12 or 25, that still works. Okay, and then down here we've got some words to go with it in case you learn best that way. We've got our visual, we've got our demonstration, and then we've got our words. Okay, in a 45-45-90 triangle, which we have, both legs are congruent. Look, these are the same. That's all they're saying. And the length of the hypotenuse is root 2 times the length of a leg. So there you go. There's root 2 times the length of the leg. Okay, that's all that says. Now let's switch gears for a minute and let's talk about the 30-60-90, and we'll talk about why it works the way it does. Here you've got 2x, x, and x, or excuse me, x root 3 and x. So x is down here. I call that the shortest side. I call this the longer leg, and I call that little guy, oh, you know this one, don't you? That one's the hypotenuse. Okay, so hypotenuse, the shortest side, and then I call it the longer leg. Okay, so in a 30-60-90 triangle, the length of the hypotenuse is twice the length of the shorter leg, doubling the length of that. The length of the longer leg is root 3 times the length of the shorter leg. So for example, if this is 10, that means this is 20, and this is 10 root 3. Let's take a look at why that is so we can try to understand it. Okay, so let's start with this triangle right here. Let's say that I had side lengths of 8, 8, and 8 in this equilateral triangle. And then I chopped this guy down the middle. I put in an altitude, an angle bisector, perpendicular bisector. Since it's equilateral, they're all the same. So I've got my 60-degree angle, and I've got my 30-degree angle. That's also 30, and that's 60. And now, since that was 8, I'm going to call this 4 and 4. So one thing that I hope jumps out at you, we now have 8 and 4. 8 is twice as big as 4. Okay, so check this out. 2 times as big as this one. Okay, 8, 4, twice as big. Okay, and then what about that other side? So I'm going to call this L, the longer leg, and I'm only going to look at this triangle on the right side for right now. Going back to the Pythagorean Theorem, which we learned in the previous lesson, if we take 4 squared plus L squared equals 8 squared, let's just see what happens. That's 16 plus L squared equals 64. Let's subtract 16 on both sides, and let's see what we get. So 64 minus 16 is 48. And we learned that we need to square root that. And then we need to take square root of 48 and break it down. Okay, so here we go. Let's break it down. That breaks into 2 and 24, which breaks into 2 and 12, which breaks into 2 and 6, which breaks into 2 and 3. Let's circle our pairs. I got a pair of 2s, boom. I got a pair of 2s, boom. I got a 3 left over. That's a loner. Okay, we're reviewing as we go, right? So then I get 4 root 3. So 4 root 3. Now here's what I want you to see from this. Whatever this is, whatever 4 is, the shortest side is. The hypotenuse is twice as long. And this right here is the same thing. It just has a root 3 written next to it. Okay, and this is one reason why it works. Now I did this one with numbers rather than in general, so perhaps, hopefully it's easier to track with. But that's all it is, y'all. So before we move on, make sure you have these two diagrams perfectly in your notes, well drawn, because that's what we're going to rely on for the rest of the video. All right, now let's try some examples. We're going to start with the 45, 45, 90 triangle, which you can see here. We got a 45, 45, 90, 45, 45, 90, and I want you to see how this works. So guys, I want you to think back to the previous picture. The previous picture had x, x, and x root 2 for the hypotenuse. Now, yes, this picture's rotated a little bit, but remember the hypotenuse always has x root 2. And I want you to write in this stuff exactly as I am. I know I'm going quickly. Pause the video so you can draw the picture, okay? I don't want to make it a 10-minute session of drawing, but go ahead and draw the picture. So if I know that x is equal to 9, then I can come right down here, and instead of x, I can write 9. So that says 9 root 2 equals h. And people, that's all it is. It's done. Okay, we just did one. That's it. Now, I'd encourage you to try this one on your own if you can. And if you can't, do it with me, okay? Okay, we learned that the short sides have an x on them. So x equals 2 root 2. And then we learned that this one, and I'm not going to call that x. I'm going to call it the hypotenuse so it doesn't get confusing. I'm going to label it just like the picture. We learned that it is x root 2. So all I'm going to do is I'm going to take x. I'm going to write it. 2 root 2. And then I also have to write this root 2. Now that could be a little bit confusing. Wait, why did you write it twice? Okay, I wrote it once because of the definition, and I wrote it another time because it was given in the question. Okay, because this right here is x. And this right here is the actual definition for a 45, 45, 90 triangle. And now we get to simplify this. So I bring down the 2. Do y'all know what root 2 times root 2 is? A lot of different ways to answer that question. What most students will say is root 4, which is totally true. Do you know what the square root of 4 is? That would be 2. So this now says 2 times 2, which equals 4. So that was our missing value. That was our hypotenuse. Okay, let's try this one. Well, packing to move, you use a square box. Yeah, obviously. You have a broom that is 5 feet long. What are the dimensions of the smallest square box that it could fit into the bottom of? Interesting. Okay, let's draw a square box. Now, if you wanted to fit a broom in, and you wanted it to just barely fit in the box, how would you lay it in the box? You'd probably lay it diagonally. That's the longest distance inside the box. And so what they're telling us right now is that that is 5. And they ask for the dimensions of the smallest square box. And since it's a square, the side lengths are the same. So I'm going to redraw that triangle now. Oops, except let me do a redo. Okay, so I got 5, I've got x, I've got x. Hey, wait a minute. Do we know any of the angles in this box? Let's see. This was a square, which means that was a 90-degree angle, and we just chopped it in half. And this was a 90-degree angle, and we just chopped that in half, which means that these are each 45. Cool. So now we're going to go back to exactly what we just learned. We had x, and we had x root 2 right there. Now, x is what we're looking for, but notice we have a perfectly good equation right here. So I'm going to write down x root 2 equals 5 where I have a little bit more space, and I'm going to solve it. I have a number next to x. It's multiplied. I don't want it there, so I do root 2. And now I have to think carefully about what I'm going to do next, because I could rationalize the denominator and get rid of that root 2, but because they asked for the dimensions of a box, I don't think they want roots in the answer. Like if you go down to Home Depot and you ask for a box of 5 divided by root 2, they will not know what you mean. So what I'm going to do is I'm actually going to type this right in my calculator and see what I get. And I get 3.54. And that was feet. So I'm going to call that feet. So x equals 3.54 feet. So the dimensions 3.54 by 3.54 on the box. Okay, what about this one? Take a minute and draw the picture. Sometimes people get a little bit panicked on this because it looks like a trapezoid. But remember, we're learning about right triangles right now, and so somehow it must connect. Now, they said there's a little 45 right here, so guess what? That angle is going to be in the triangle. There's no doubt. And so we need to draw in an extra side. Maybe pause the video and think for a minute about where could you draw in an additional side so that this question looks like what we've been learning so far. That spot is right here. Okay, and I mean to draw that straight down. I'm not quite perfect. If I make that 90, I've got 45. And I've got 90 right there. Okay, so now I'm going to label the stuff I know how. I know the distance from here to here is, hey, you know this one, don't you? That's 8. Now that's not A. A is the entire distance, so I'll also need to find how long this is. We'll do that in just a minute. Okay, this is 6, so this is also 6. Now remember, in a 45, 45, 90 triangle, the two legs are the same length. So this little guy right here is 6. So what's A? Well, it's 8, and then it's 6 more. So A equals 14. I haven't even really written any equations yet. I can tell you what that is. And now we're going to focus just on this triangle because we need to find B. In a 45, 45, 90, we said that this was x, and that was x, and this was x root 2. And since we know what x is, we'll just write it in. 6 root 2 equals B. And y'all, that's all it is. So the hard part is this right here. We got to fill in that line. Sometimes you have to add a little bit of extra information to your picture so that you can be successful. Now let's switch gears a little bit and let's go to the 30, 60, 90 triangle. And so what we're going to remember is that on this triangle, and please make sure you pause the video so you can draw it, otherwise this may go too fast for you. What we want to remember is that on the very shortest side, and look back in your notes if you need to see this, the shortest side we said was always x, and the hypotenuse was always 2x, and the longer leg was always x root 3. Now folks, here's what you do. You label it up, and you're going to have 3 equations. Typically, only one of them will be a solvable equation. So what I mean by that is right here, there's 2 variables, not solvable. F and x, that's 2 variables, not solvable. 5x root 3, that's only 1 variable, so that's my solvable equation. So that's the one I'm going to pick. Okay, let's divide by root 3. We are not technically allowed to have irrational numbers in the denominator, so we're going to rationalize it. Now, folks, take really good notes on this. What I'm going to do is if I see the root there, I'm going to put another one here and another one there. Why is that legal? Because this number right here, something divided by itself is 1. We just multiplied by 1, and we know that doesn't change the value. Now, let's rewrite what we have. Now, the way a lot of people like to write this is 5 root 3. A lot of people, especially when they're just learning, say, oh, 3 times 3 is 9. So that's square root of 9 equals x. And then square root of 9 is 3. So that's 5 root 3 over 3 equals x. Now, folks, x we know is the same as what? Look at the picture. X is the same as d. So we're going to say that that's d. So we just found side length d. That's awesome. Now we need to find f. F says that it's just 2 multiplied by x. And we already know what x is. It's 5 root 3 over 3. So here's what I'm going to write. F equals 2 times 5 root 3 over 3. All we're going to do is combine like terms. So what I mean by that is 2 can be multiplied by which one of these? 2, 5, root 3, or 3. The 2 and the 5 go together really, really well. So that's going to be 10 root 3 over 3. And folks, that's done. Okay, let's try this one. This may be a really good opportunity for you to try labeling it up all by yourself. Okay, now I run into a little bit of a challenge with the labeling because I've got x right here, and normally we labeled x down here. So here's what I'm going to do. For the moment, I'm going to cross those off and realize that I need to find both those sides. So I'm going to say that this shortest side is x. That's what the original drawing that we learned about was. And look back in your notes if you need to see that. The longer side is x root 3. and this side is 2x. So here I go. If x is 1, then x root 3, that's 1 root 3, and we had said that was y, so y equals 1 root 3, or if you want to simplify it, just root 3. Okay, that part's done. And then this is 2x, so that would be 2 times 1, which is 2. And what was that? That originally was x, so I'm going to say that now is x. And what I'm going to do is I'm going to go back and I'm going to erase this initial work, because now that I do that, I have complete and accurate work for this question on my page, because I've said, hey, x is 2 and y is root 3, and that's done. Okay, and here's our final question, and then we're going to wrap up for today. Okay, I'm going to label this one up. Okay, normally the shortest side is x. Hey, that was really generous. They labeled it for us. The longer side is normally x root 3. And the longest side is normally 2x. And so what I'm going to look for is, of those three equations, which one do I know how to solve? It is absolutely this one on the hypotenuse. And so I'm going to divide by 2. And so I get 15 equals x. So I can say, hey, x is 15. I just answered that part of the question. And then down here, that says x root 3. So equals 15 root 3. And this, folks, is done. Okay, so it's a little bit intimidating at first, maybe. But notice, there's not a whole lot of steps. Okay, once we get really good at labeling the pictures, we're going to be really successful at these. Okay, I hope today's video was helpful and enjoyable for you, and we will see you next time.